Hello everyone and welcome back to Netmaster Zone channel. If you saw the previous video, we just did some very basic configuration in the management, and we configure our management interface and also some certificate for that to access that securely. Now in this video, let's go and start our configuration with the zones and also with the interfaces. For that, first of all, let's go to the network, and in the network, let's go to the object first. I'm going to create some tag and assign our inside, outside, and DMZ in this tag for better visibility and better management. Let me name that inside and select a color for that. The inside is forest green. It's good. Another one for outside, and for outside I'm going to use color red, and one more I'm going to create it here. Let's name that DMZ, and for DMZ let's orange. It's okay. And now we have three different tags, and according to these tags we can tag our IP addresses and also our zones and also interfaces with this for better visibility. Let's go to the network, and here I'm going to, first of all, let's create some zones. If I go to the configuration of the interface, I need to assign this interface to the zone, but I don't have any zone here. Let's create zone inside. I'm using this inside and outside concept from Cisco, but of course you can change that to trusted, untrusted, or any other name that you prefer. Inside, and let's create another one, outside, and select the type as a L3 zone, and one more for DMZ. Let's tag that, change that to layer 3. Okay, this is enough for now, but in the future we will create more for site-to-site VPN and maybe for remote access VPN, the global protect. Okay, the zone is created. Next, let's go to the virtual router, and here in the virtual router you can see there is one default is available. What is virtual router? The virtual router is something like VRF, and it means that you can add your interfaces in this virtual router, and that interfaces and that routing table will be managed by this virtual router here. You can create another virtual router, but this route will never mix to each other, and also the policies that you are creating for the new virtual router will not mix with this one. Let's change this default, and I'm going to create a new one. I'm going to name that router 1 as a virtual router. Let's save that. We'll configure route here later, but for now let's go and create and configure our interfaces. Let's go to the diagram. Ethernet 1 by 1 and 1 by 2 is in the zone inside here, green, and 192.168.1.0 and 2.0 is for these two interface. Let's configure that Ethernet 1 by 1. If you have any comment you can type it here, but interface type it's layer 3. And for the virtual router you can see it comes here, and we can select that. I don't have any NetFlow profile for now. Maybe in the future we can create that. And zone it's belong to zone inside. Next, let's add the IPv4 address to that. It's 192.168.1.1/24. Let me confirm that. 192.168.1.1 is here, and 2 is configured in the switch 10. Okay, this is the IP address, and if you have any IPv6 configuration for SD-WAN, we don't have license again. And then in the advanced, you can see that we can configure some other information like ARP and NDP proxy, quality of service, something like that. But here, let's for the management profile, okay, let's do it later. For now, I'm going to show you that later. It will be better. Then let's go to Ethernet 0x2 and configure that one. It's layer 3, virtual router 1, and zone insight. IP address 192.168.2.1/24 according to our diagram, and we don't have any other configuration here. Let's okay this, and now let's go and configure our DMZ. It's 1x3 and the IP address is 192.168.3.0. This one also is L3 in the same virtual router, belong to DMZ zone, and the IP address 192.168.3.1/24. Let's save this. And next two interfaces is connected to the outside. It's 1x6 and 1x7 with 192.168.100 and 200. This type in the Palo Alto side, the IP address is 2 and 1 is configured in this ISP1 and ISP2. Ethernet 1x6, let's change the type to L3, belong to router 1 and belong to zone outside. IP address 192.168.100.2/24. Let's save this one, and the last one, it's L3, router 1 and belong to outside. The IP address 192.168.200.2/24. Let's save this one, and one quick verify 192.168.1.1 for Ethernet 1, 2.1 for Ethernet 1x2, and 3.1 is for DMZ, and 192.168.102 and 202. These two is belong to outside. Okay, now let's commit these changes, and then we'll come back and configure some route also. If there is any mistake during the configuration, for example in the range or in the type of IP address and so on, in that case, in the detail it will not commit, and it will say the commit is failed, and it will tell you the error, that what error you made here, and you can come back and fix the problem and commit it again. But for now, let's wait for this to commit. Let me close that. Of course, you can come back in the task and see any pending commit here. Okay, during this time, let's go and configure some route here. You can see that the Palo Alto is connected to ISP. Then in this case, if we want to send any traffic to outside, we need a default route to send everything to the ISP1 or ISP2. Let's configure this too. For that, we are going to network, and in the network, let's go to the virtual router. We just created a virtual router before, and now let's edit this virtual router. You can see this interfaces we just configured. Now it's belong to virtual router 1. Let's go to the static route, and here let's create our first static route here. I'm going to name that default route to ISP1, because we have two connection, one to ISP1 and another one to ISP2. In that case, let's name that to understand which one is belong to which ISP. Now I name that default route to ISP1, and destination is 0.0.0.0 is a default route, and to the interface 1/6, because the interface 1/6 is connected to ISP1, and the next route, the next hop IP address is 192.168.100.1. This 100.1 is configured in this interface E0/0 of ISP1. And here you can see the admin distance and also the metric. Let's give admin distance 10 here and also metric 10. Why 10? I will tell you in the next. Let's create another one. Not create, I'm going to clone this to make everything easier. And here let's name that to ISP2, and ISP2 is connected to 1/0. Let's type the default route again. It's going to send it to Ethernet 1/0 and to the next hop IP address of 192.168.200.1. And this time I'm going to make this admin distance and metric to 20. This administrative distance and metric, these two actually helps us to make it prefer. For example, we have a better connection and fast internet on the ISP1, then we use this route 1 as a preferred route. Everything will go through this because it has a better metric, and it will send all the information through this path. But in case if the ISP1 is down, then we should be able to send the traffic back and to the ISP2 as a backup. For that, of course, in the Palo Alto, we have a configuration. We need to make that configuration here. I just click on the default route that I configured before, and now we have a path monitoring option here. In the path monitoring, of course, you can make a criteria, and according to that criteria, it will check the path. If the path is down, then it will delete this route from the routing table and then add the other ISP route to the routing table. Then all the information will send through this. When this route comes back, this ISP1 comes back, in that case again it will preempt and will take its rule back. Let's create this path monitoring also. I'm going to click on add, and I name it path monitoring, and let's ISP1, and enable source IP address. It's 192.168.100.2. This is the IP address of the outside interface. I'm going to send ping from this to any destination IP address. Here I'm going to send it to 8.8.8.8. Of course, we can create let me see if it has any option to create. No, unfortunately it doesn't have any option to create a address group of this. It means that we can only add one IP address here. In this version it may not be available, and then it will send ping every 3 seconds, and if that ping doesn't come back, ping on after 5 times, it will delete this route from the routing table and will add the other route to the routing table. Then the information will go through this ISP. We will test that later. And here you can see the preempt when the route comes back because it's continuously ping the destination 888. When the ping comes back after 5 times, then it will in 2 minutes it will just preempt and take its rule back. Let's make it 1 in the lab. Of course, in the real environment you may change it for 15 minutes to make sure that everything is stable. Then you just preempt back to the ISP. But here in the lab I'm using 1 for testing to make everything faster. Okay, now the default route is, the first default route is created here, and this Palo Alto should be able to ping to ISP1. I wanted to show you something here. Let's go to ISP1, and from ISP1 I should be able to ping to 192.168.100.2. This is the IP address that we just configured for the interface Ethernet 1x0 in the Palo Alto, and you can see this ping is unsuccessful. And if I go, for example, in switch 10, here let me show you, do show IP interface brief. You can see that I have a VLAN 10, and this Ethernet 0x0 should be in the VLAN 10. Do show run interface is 0x0, and it's belong to VLAN 10. It means I should be able to ping to 192.168.1.1. That is the IP address of Ethernet 1x0 in Palo Alto. But this ping is unsuccessful, and the reason is because the firewall doesn't let anyone to ping its interfaces. To changing this behavior, let me show you how you can do it. Let's go to the interfaces, and in the network interface, and now Ethernet 1x1. Here in the advanced, we need to create a management profile, and then add that management profile here to allow any service that we want to. For example, if I want to access this management interface through this PC, because this management is not allowed in the inside interface, this PC will not be able to access the management interface. The management interface will be only accessible through this management interface. But we can change this behavior here. Let's go and first in the network, in the management interface, let's create a interface management profile. Let me name that allow, for example, ping. I'm going to allow the ping here, just selecting ping. Of course, you can enable the SSH, Telnet, HTTPS, and this other SNMP and other services that is available here. I'm going to add that. And also, of course, you can add a range of IP address. You can say, for example, this range of IP address are allowed to ping this firewall or to access the HTTP server and so on. But let's delete that. I'm going to allow everything, and again commit. With this commit, we just allow ping in the interface of Ethernet 1x1, and also we just configure some route, default route in the default router, in the router 1, and also some fallback if any if the ISP1 is down, then it will go to ISP2. Okay, let's wait for this commit to finish. But after that, let's go and make sure that we also have a route to the inside. As you saw here in this switch 10, I have two interfaces here. The VLAN 1 is 10.10.2.1. it's this two PC and server is connected to this VLAN, but it's not directly connected to the firewall. In that case, of course, we need a route to the firewall to knows that this two IP address, this range of IP address is connected to its inside. I'm going to use a RIP here. Of course, we can use a static route and also OSPF, but let's make it very simple and use a RIP protocol for this. You can see here that we have a RIP, OSPF, OSPF v3, BGP, and also multicast for this virtual router. Let's configure RIP here, and here let's add the interface. I'm going to add interface one by one to add it in the RIP process. Let's enable that. And also I need to send the advertised default route here. When, for example, this PC wants to access the internet, it needs a default route to be available in the switch 1 to knows to send this traffic to the firewall 1. Then I'm going to advertise this default route. The other configuration, timers, and other auto profiles and export rules, let it be by default. And let's save this configuration. And also for Ethernet 2, I'm going to add in the RIP also interface Ethernet 1 by 2, enable that, and also advertise the default route here. Okay. And I believe we should add that in DMZ also, because DMZ also needs a route that is 1 by 3, and advertise default route. Okay. Now the RIP is configured, and we need to configure the RIP process here in the switch 10. I believe it's already configured here. Show run section RIP. Yes, you can see that one thing else, that by default you didn't see any information about the RIP version in this firewall, because by default it's RIP version 2. It doesn't support RIP version 1. And make sure if you configure that in your switch to change this to version 2, else it will not make a neighborship with that. And also I add this to network, the 10.10.0.0, 10.0.0.0 and 192.168.1.0, and also this command no auto summary, because I have two sites here and both of them belong to 10, and if I don't use the no auto summary, it will summarize that to 10, and it will advertise from this two switch same IP address to the Palo Alto firewall, and then it doesn't know that 10.10 is connected to this link and 10.20 is connected to other link here. Then auto summary is very necessary here, else you will not to be able to make the Palo Alto will not be able to make a correct decision. Okay, the RIP is also configured here. Let's commit that. And next let's go and check this routing table to make sure that this configuration is available here. By default, intra-zone communication is allowed in the Palo Alto firewall to ping each other. For example, now I should be able to ping from VPC1 to VPC2 because both of them is connected to zone inside. But I will not be able to ping from VPC to internet because it's not allowed to access from inside to the outside by default. Let's check that. Let me try show IP. If it has IP address, yes, it has 10.20 0.12 and VPC in the other side. Show IP, it's 10.2.51. Let me ping the other one, 10.20.0.12. 12. If the rep configuration is configured correctly, now I should be able to ping, and you can see I'm able to ping this IP address from VPC in the site A to site B, and both of them is going through this inside interface in the Palo Alto. Okay, the routing configuration is okay now, and let's do something else. Next, to access the internet, for example, this PC wants to ping to 888. Let's try that. Ping 8.8.8.8, and you can see that this ping it's not successful. It's because first, we don't have any NAT policy, and second, we don't have any security policy to allow this route to outside. For that, let's first of all, let's go and configure a NAT. NAT is in the policy, and second option, NAT. Let's create a NAT here. Add. Let's name it into out, for example, ISP1 again, because we have two ISP and we need to NAT this network to both of them. NAT for ISP1, everything okay here. The original packet, let's add it from inside. The destination is going to outside. Destination interface, of course, it's 1x6. 1x6 is connected to ISP1, and for the service, let it be any. And also for the source address and destination address, we can configure here. By default, it's any, but let's do something. Let's configure to address object and add our sites in this objects. For this, let's make site A. It's site A, and the IP address for site A is 10.10.2.0/24. Let's save that. Let me show you here. This is site A, 10.10.2.0. I'm going to create an object network and also one object network for site B. We can create it directly from here, or we can go to the object and create that object from this object tab. But now we are here, let's create the other one from here also, and let's name that site B. The site B is 10.20.0.0/24. It's a IP address and mask. Of course, we can make a range, or we can make a wildcard or FQDN. For now, let's use this, and okay. And also, we can create a address group. It means let me make it inside zone. Name it inside zone. Inside zone, let's name that inside zone IPs, and I can add site A and site B in that. In this case, it doesn't need to select these two because both of them is available in this site A and site B IP address. Both of them is available in this object network here. And for the destination, let it be any. And for the translated packet, I'm going to use the dynamic IP and port. And for the address type, let's select the interface, because we are going to NAT to the interface. Which interface? Interface 1x6. And the IP address of that is 192.168.100.2. Okay. Now we just create a NAT from security zone inside to the outside, and in the outside is going to NAT it to interface 1x6, and these two IP addresses allowed, and this is the IP address of the outside interface. We need another NAT also, and that is for ISP 2. Let's select this and colon. I'm going to colon that. Okay, and now let's edit it. Into out ISP 2, everything is same, inside to outside, but this time it's interface 1/7, service any, the source, everything, and translated packet, everything is same, just we need to change the interface and of course the IP address. Okay, now we have two NAT here, and when I try to access the outside, these two NAT will act and will NAT my traffic. Next, we need to have a security policy here, because this is a rule of every firewall. Actually, I can say the main rule of every firewall, to have a security policy and to allow the traffic between different zones. And here you can see I have two default security policy that is created here, and as I said that intra-zone traffic is allowed, and because of that we will be able to ping between this to site A and site B in the inside interface. But interzone by default is denied. It means when I try to ping it from inside to outside, from my site 1 to internet, it will not be pinged, and you can see the hit count of that when we tried before. Let's create a security policy here and allow our zones to go to outside. For that, let's name it, first of all, let's need a name. Let's name it in to out, inside to outside, source zone is inside, and source address, let's select inside zone IPs, it's site A and site B. The user and source device, any, let it be any, because currently we don't have any user and we don't want to limit it to the any device. And for the destination zone, it's outside, and destination address is internet, and it's wide open, and we are going to leave everything any, and also the destination device same, the application and also the service and URL category, these two let be for now we let them to be wide open, but in the future videos of course we'll configure some category and some application to allow it to inside. And for the action is allowed, and I'm going to log out start session, but I don't have a license, and it's very disappointing that the Palo Alto doesn't let us to see the log without license, and sometimes it's very difficult to find the problem if we make a mistake without log. Actually 90% of all problems is very easy to find in the log, but unfortunately Palo Alto doesn't show that. Okay, let's save it. Now from inside to zone out this IP address to zone outside, and all the application and all category is allowed. Let's commit it and let's wait for this commit to finish. Now what actually we did here, first we configure our interfaces, then we configure the route to the outside. Now we have a default route to the outside, everything comes to the firewall, it will send it to one of these two ISPs. Second, we just make a route to the inside. When the traffic back, then the Palo Alto will be able to send it back to our sites here. After routing, we configure the NAT. We add one NAT on interface 1/0 and another NAT on Ethernet 1/7. These two NAT will help us to send our private IP address and NAT it to the public IP address, because this private is not accessible through the public internet. Then we create a security profile, a firewall rule, to let the inside zone to be able to access the outside here. And when the commit is finished, we should be able to ping to 8888. Okay, the configuration is committed successfully, and we don't have any error. That is very good. Let's close this, and let's try to ping to 888, and you can see here that I'm able to ping to 88, but as I said, unfortunately it doesn't show any traffic log here, and also any thread, nothing. The only information that we can see in the log is about the system. The system information is logged here, but you can see we just configure this different routing, and also some changes in general information and so on. But unfortunately the traffic log is not available. Okay, now let's verify the configuration that we have made before. Actually, what we are going to verify, we have these two sites, and we configure everything here. We have NAT here, and also route for two different paths, and also I just configure a path monitoring here. If this path is down, it should redirect it to the other path. Let's actually first check that we have a connectivity to the internet, and then we can also check this path, if this monitoring that is working or not. Okay, let's go to the windows that I have here. This is the windows that I just turned it on. It's located here, and I'm connected through this management to its remote desktop. Let's go and try to ping to a public IP address. Let me ping to 8.8.8.8, and it's working. Okay, let's ping to a name, google.com, and also I can ping it, there is no problem. And now let's browse some websites. Let's, for example, go to PayPal. And it seems that it's working, and it's now browsing to PayPal website. But let's also do some click to make sure that it's not in the cache. Okay, it's working, there is no problem. But let's do something. Let's first go to our PC, and here let's try to trace the route and see what path the PC will take to go to the internet. Trace route to 8.8.8.8. Okay, first it should go to its gateway, that is okay, it's here. The IP address is configured in the router in switch 20, and then it's going to 192.168.2.1, and we configure that here in the interface Ethernet 1x2. Next, it's going to 192.168.100.1, and that is the ISP1 IP address. We just configured that in Ethernet 1x6 before, and the other side is configured .1. Then it's going, of course, to the this network router, and also it's go to the internet. And because I have so many firewalls that configured here in my lab, it's not requesting, it's not tracing that firewalls. Okay, it's enough that we know the route it's going through this ISP1. Now let's do something. Let's put a ping here, a continuous ping, and let's turn off or shut down the ISP1 one of its interface. I'm going to turn off this interface and disconnect it from the internet and see if it's going to fall back to the other link. Let's go to configuration terminal and interface 0x1 and shut down. Okay, 0x1 is shut down. It means that this ISP doesn't have internet anymore. And now let's go to here and see. You can see that we are just losing some ping and some packet is losing here. Now let's wait and see if it can recover and go to other path. Yes, you can see that it's just switch it to the other path, and this time if I try to trace it, it should go through 200.1. It means the ISP to here, we just configured 200.2 here, and 200.1 is configured in ISP2. Let's see, it's going to the inside interface, and now it's good enough, and you can see 192.168.200.1. it means that the route is just switched to the new ISP. Let's do this continuous ping here, and let's turn on the interface. No shutdown. And now after according to our configuration, after 1 minute the route should come back, and let's see if we can see any change here or any drop of packets during the ping or not. Then we can trace it and make sure that the route is going through the old path. Let me run CMD. Let's try trace to 8 in another terminal. Trace RT 8.8.8.8, and to make sure that it's going through which path now. It's the path. If the path is recovered, it should go back to its old because of better distance. No, it's going through 200. Let's do it again. In 1 minute it should just recover the old path. Yes, you can see that now it's just recovered it back, and the ISP1 now taking the role of transferring this traffic through my inside network. Okay, I believe we verify everything that we configured. And here if we go to our FortiGate and in the policy, you can see in the security policy we should have some hit count here. That is because of transferring this information, the ping and also the websites, and also the other one that is the intrazone. Intrazone, it means that between site A and site B in the same zone inside, and also some drop that we have here in interzone. Okay, and if we go to the NAT, in NAT also we should see some hit count here. That is because we are NATing our traffic. And let's see. Yes, you can see here that I have a hit count in NAT to ISP1 and also on NAT to ISP2, and it means that both of our NAT is working well and there is no problem here. Okay, for now I believe we configure everything for this video and also verify our configuration. In the next video we'll continue our lab, and I'm going to configure some deep packet inspection. It means to open the HTTPS website to verify by the Palo Alto Firewall to make sure that there is no virus or no any hidden code inside, and then we can sign it back and send it to the PC. Okay, for now, thank you for watching, and see you in the next video soon.